Hi everyone, I hope you've gotten all right with the questions over the Christmas period. Thank you for all the requests that we've had. I'm going to crack on with them. So the first one that came through was question 7, which is this one here. I hope you can see it all okay. We are given an algebraic fraction here on the left. This is a top-heavy or an improper fraction. If we expand the denominator, then we get an x squared term, but on the top we've got 2x squared term. So the numerator is greater than the denominator. So we have an algebraic improper top-heavy fraction here. What that means is, just like you can split something like, I don't know, 12/5 into a mixed number, which would be 2 and 2/5, we can do the same thing algebraically. So we can get a whole expression, which would be the equivalent of this thing here, plus some fraction or fractions afterwards, which is equivalent to this bit here. So first of all, we're asked to find the values of the constants a, b and c. Now to do that, just like we rewrite 12/5 as a mixed number by dividing 12 by 5, how many times does 5 go into 12? We're going to do the same thing here. How many times does this quadratic in the denominator go into the quadratic in the numerator? And to do that, we need to do some polynomial division. So first of all, I'm going to expand my denominator. So we've got x squared minus x plus 2x minus 2. And now I'm going to do my polynomial division. So I want to know how many times does x squared plus x minus 2 go into 2x squared plus 5x take 10. So we'll start with our 2x squared here. X squared times is by 2 to get 2x squared. So multiply by 2 down here. That's 2x and that's minus 4. Then we've got to make our adjustment. So we want 2x squared plus 5x. We've currently got plus 2x, so we need to add another 3x in there. And we also want minus 10, but we've got minus 4, so we need to subtract 6. Now, because the degree of this, which is 2, is greater than the degree of this, which is 1, because it's x to the power of 1, we know that all of this bit here is our remainder. So what I know is that the fraction above, all of that, is equal to this 2 plus the remainder over the original divisor, which was x squared minus plus x minus 2. I could keep it in factorised form or I could leave it like that. Now, this is still not in the form that we want it. This needs to be split up into partial fractions. So actually I am going to put it back into a refactorised form. And then this bit here, I'm going to perform partial fractions on. So 3x minus 6 over x minus 1, x plus 2 is identical to, now ordinarily I would write a over x minus 1 plus b over x plus 2, but because we use b and c here, I'm going to use those. So b over x minus 1 plus c over x plus 2. So what that means is that 3x takes 6 is identical to b lots of x plus 2 plus c lots of x minus 1. This is a process that you learnt in lessons. Let's pick some values for x because we know that an identity is true for any value. We can use any value for x in here to work out b and c, and we choose them judiciously to eliminate one or the other of the terms. So let's let x equal minus 2 first of all. Check my mental arithmetic now. I'm so tempted to jump to the calculator, but I'm not going to. So we've got minus 6 take 6, which is minus 12. This would become 0. This is minus 3c. So c is minus 12 over minus 3, which is positive 4. And then secondly, we'll let x equal positive 1 so that this bracket here turns to 0. So we've got 3 take 6 is minus 3. Then we've got 3, that's the 1 here plus 2, so 3b. So b is minus 3 over 3, which is minus 1. The fact that they've come out as very nice numbers means I'm almost certainly haven't made a mistake. So what I can say, therefore, is that the original fraction, I'm going to write it out full so it's really clear for you, is identical to 2 plus this fraction, but that fraction is identical to this with b and c as we've found. So minus 1 over x take 1 plus 4 over x plus 2. Now I want to point out something here. This plus minus 1 I could also write like this. So either of those is a correct version of the answer. Now let's go on to B. Hence, or otherwise, expand this fraction, which you'll notice of course is the fraction from part A, in ascending powers of x as far as the term in x squared. So this means they want us to do a binomial expansion. So let's take this fraction here but go straight for writing it out in this format. So we've got 2 take 1 over x minus 1 plus 4 over x plus 2 is identical to 2 plus, and now I need to do my binomial expansion. I should have written a minus there, my apologies. 2 minus. Now I need to do binomial expansion on this fraction here, but that, bear in mind, is x minus 1 to the power of minus 1. I'll also do it on this one at the same time. That's 4 lots of x plus 2 to the minus 1. So let's do my first binomial expansion in a square bracket, so that's this here. Now I need to bear in mind that this still isn't in the right format, because for the binomial expansion to work I need to have it in the form 1 plus. So first of all I'm going to rewrite this as minus 1 plus x to the minus 1, but I need that 1 to be positive, so I'm going to take a minus 1 out, which makes it 1, and then minus x here. All of that is to the power of minus 1. So minus 1 to the power of minus 1 means 1 over minus 1, which is still minus 1, so that's okay. And then there. This one I need to do work on as well, so let's do that while we're at it. We'll do it all together. So we've got 4 lots of 2 plus x to the power of minus 1. That gives us 4 lots of, and then bring out the 2, and we've got 1 plus x over 2 to the power of minus 1. Now notice I'm not applying the power of minus 1 to the 4, because the 4 was in the numerator. The 4 didn't have a power of minus 1 in the first place, only the x plus 2 did. So the only bit that has the power of minus 1 applied is the x plus 2 bracket, which is the bit I'm working with now. So 2 to the power of minus 1, and then 1 plus x over 2 to the power of minus 1 as well. So I've just applied this minus 1 to both parts of the bracket, the square bracket. 2 to the power of minus 1 is a half, 1 over 2. So now I'm going to multiply the 4 into here. So we've got 4 times a half, which is 2, and then 1 plus x over 2 to the power of minus 1. Now, a lot of work to get there, but we've got to the point now where both of these can be expanded using the binomial expansion. So let's come back up here. We've got, first of all, 2 minus, and then minus 1 lots of this bracket will expand. So instead of writing a minus 1 in here, I'm just going to put a plus 1 there. And I'm going to expand the 1 minus x to the minus 1. So that gives us 1 plus n x plus n minus 1 over 2 factorial x squared. I'm not going to go any further because it only wants me to go to the term in x squared. And now, let's just get that out of the way. Let's do the second bracket, which is 2 lots of, coming to this now, 1 plus n x, which in this case is x over 2, plus n minus 1 over 2 factorial x over 2 squared. And this, of course, will give me my x squared term. I just need to tidy these up now. So, keeping my big 2 there, we have, because this bracket is added, I can just write these terms as they're meant to be. So we've got 1 plus, this term is x. This is, well, that's 2 divided by 2, so this is all just 1, x squared. So that's all of that bit. Then I'm going to keep this as it is for now with the 2 outside while I just tidy this up, because it's important to go slowly and just take each step at a time, else you make silly mistakes and miss things out. So here we've got 1 minus x over 2 from there. Then here, that's positive 2 divided by 2. So that's all just 1. So this is plus x squared over, don't forget to square the 2 in the denominator, 4. I'm using this plus dot 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 to kind of incorporate both of these extensions now, because we know both of these are infinite expansions, so the whole thing's just an infinite expansion. So let's tidy this up. We've got 2 plus 1 plus another 2 from there, so that's going to be 4, 5. I'm going to cross these off as I go because I'm notorious for making mistakes and missing them out. Then here we've got 1x. Here we've got 2 lots of x over 2, so that's a 1x, but it's being subtracted, so 1x minus 1x gives us no x's. And then we've got our 1x squared. Here we've got 2 lots of x squared over 4, so that's a half x squared. So 1x squared plus half x squared is going to be 1.5 x squared. And that is the final answer, giving each coefficient as a simplified fraction. Yes, I've done that, and I'm finished. So that's question 7 for you.